Hey everyone, welcome back to NexMEP. I'm really excited for today's session because we're continuing our deep dive into circuit breakers. But before we begin, a quick recap of part 1. We covered 4 essential circuit breakers: MCB for small home circuits, MCCB for heavy industrial loads, RCCB for shock and leakage protection, and RCBO, which combines all 3 in one device. If you missed it, the link is right up here, go check it out. Today in part 2, we're going to explore 5 more critical types: ELCB, ACB, VCB, SF6, and the oil circuit breaker. And at the end, I'll show you a full comparison chart of all 9 types side by side. So stay with me till the end, it's going to be super informative. Let's start with the ELCB, the earth leakage circuit breaker. So what exactly is an ELCB? It's a safety device that protects you and your electrical system from earth leakage and electric shock. The moment it detects leakage current flowing to the earth, it trips and disconnects the power supply automatically. Now, how does it actually work? The ELCB continuously monitors the current. When some current escapes through an unintended path, like through a person or faulty insulation, instead of returning normally through the neutral, that's called leakage current. The ELCB detects this imbalance and trips immediately. You'll find ELCBs mainly in older residential panels, older electrical installations, and some industrial systems. One important thing: ELCB is older technology. It has been mostly replaced by RCCB in modern installations. And remember, it does not protect against overload or short circuit. It only handles earth leakage. Next up is the ACB, the air circuit breaker. This is a heavy-duty breaker used for high current, low voltage applications. So what makes ACB special? When a fault occurs, whether it's an overload or a short circuit, the ACB trips automatically. And when the contacts open, air is blown across the arc, which cools it down and extinguishes it. That's why it's called an air circuit breaker. Air is the arc quenching medium. ACBs are commonly used in LT panels, main distribution boards, commercial buildings, industries, and as the main incomer protection in large facilities. The typical current range for ACBs goes up to 6,300 amps, so this is a very powerful breaker. One standout feature is the draw-out mechanism, which means you can pull the breaker out for testing or maintenance without disconnecting the power cables. That's really useful in live industrial environments. Now let's talk about VCB, the vacuum circuit breaker. Moving up from low voltage, VCB operates in the medium voltage range. The arc quenching medium here is vacuum, and vacuum is an excellent arc extinguisher because there are no particles to sustain the arc. When a fault is detected, the contacts inside the vacuum interrupter separate, the arc forms, and it gets extinguished at current 0, almost instantly. VCBs are your go-to for 11 kV substations, medium voltage switchgear, and industrial power systems. The voltage range is typically up to 33 kV. What makes VCB so popular in modern systems? High reliability, virtually zero maintenance, compact size, and it's environment friendly. The vacuum interrupter is sealed, so you don't need to refill or check any gas or oil. It's maintenance free in the truest sense. Type 8 is the SF6 circuit breaker, and this is where we step into high voltage territory. SF6 stands for sulfur hexafluoride, which is a special gas used as both the insulating medium and the arc quenching medium. When a fault occurs, the trip unit signals the operating mechanism. The moving contacts open inside the SF6 gas chamber. The arc that forms is immediately absorbed and extinguished by the SF6 gas because of its excellent dielectric and thermal properties. SF6 breakers are used in high-voltage power substations, transmission systems, and high-voltage switchyards anywhere above 33 kV. Key features: excellent insulation, high braking capacity, low maintenance, compact design, and SF6 gas is recyclable, so it's also environment friendly. One thing to note: SF6 gas is non-flammable, non-toxic, and pressure is continuously monitored inside the tank by a density monitor. Last but not least, the oil circuit breaker, or OCB. This is one of the oldest types of circuit breakers still found in older power systems. Here, the contacts separate inside a tank filled with insulating oil. When the arc forms, the oil around it decomposes, generates hydrogen gas, which helps cool and extinguish the arc. So oil serves a dual purpose: insulation and arc extinction. OCBs are found in older substations, high-voltage installations, and industrial power systems. The voltage range is typically 11 kV and above. Now, what's the limitation? OCBs require regular maintenance. The oil needs to be checked, filtered, and replaced periodically. They're bulky, heavier, and have a fire risk if oil leaks. That's why today, OCBs are mostly replaced by VCBs and SF6 breakers in modern systems. But understanding OCBs is important for maintenance engineers working with legacy systems. Alright, this is the slide you've all been waiting for, the complete comparison of all 9 circuit breakers. Let me walk you through it quickly. Starting with MCB, small circuit breaker for homes, up to 100A, thermal magnetic mechanism. MCCB, for heavy industrial loads, up to 2500A. RCCB, protects humans from shock, 25A to 100A, current imbalance detection. RCBO, the all-in-one, combines MCCB and RCCB functions. ELCB, older earth leakage protection, replaced by RCCB. Now the bigger ones, ACB handles up to 6300A for low-voltage main incomers. VCB goes up to 33 kV for medium-voltage substations. SF6 handles 33 kV and above for high-voltage transmission. And OCB, older high-voltage systems from 11 kV upward. The key takeaway? As the voltage and current go higher, you need more sophisticated arc quenching, from air to vacuum to SF6 to oil. So let's do a quick summary before we wrap up. MCB, small circuit protection for homes and offices. MCCB, heavy industrial load protection. RCCB, human shock and leakage protection. RCBO, complete electrical protection in one device. And the big four for industrial and power systems, ACB, VCB, SF6, and OCB, each suited to different voltage levels and applications. I hope this 2-part series on circuit breakers has given you a solid foundation. Whether you're an MEP engineer, an electrician, a student, or just someone passionate about electrical systems, this knowledge is gold on site and in the field. If this video added value to your learning, smash that like button, it truly means the world to me. Subscribe to NexMEP and hit the bell so every new video lands straight to you. Got questions? Drop them in the comments. I personally read and reply to every single one. And hey, your next breakthrough is just one click away, so check out the related videos on your screen right now. Until next time, keep learning, keep building, and I'll see you in the next one.